Hello everyone, my name is Phimnada Chirachotsuphaphat. Today, I am presenting a technical overview of OpenCode, an AI coding assistant designed specifically to meet the demands of modern software development. As development environments become more complex, the need for tools that integrate seamlessly into a programmer's existing workflow has never been greater. To start, OpenCode is an open-source tool that operates directly within terminal and IDE workflows. It is designed to improve productivity without disrupting the natural way developers write code. The core philosophy behind this project centers on three pillars: flexibility in model choice, strict privacy through local options, and deep integration into the developer daily environment. The motivation behind this tool is the context that many developers face today. Often, developers are forced to switch constantly between their code editor, a web browser, and external chatbot, which break concentration and fragment the workflow. Additionally, many existing tools have a limited understanding of the overall project context or raise significant privacy concerns when they require sending proprietary code to cloud-based servers. OpenCode addresses this gap by acting as a proactive partner throughout the entire software development lifecycle. Beyond simple text completion, it provides comprehensive support for a range of complex tasks. This includes intelligent code generation, automated debugging of existing errors, architectural refactoring to improve code health, and the creation of dynamic documentation that evolve alongside the project. To make this possible, the platform features a flexible backend with multimodal support. It is notable for allowing local-first or hybrid AI usage, which ensure that sensitive code can stay private on a local machine rather than being transmitted externally. Because it is open source, the system is highly customizable, allowing developers to adapt the assistant to their specific project requirements or organizational standards. Moving from the concept to the actual application, the following demonstration will show how this feature appears in a live development environment. First, this is the command used to install OpenCode directly from the terminal. With just a single command, user can quickly set it up in their environment. And beside the terminal version, OpenCode also provides a desktop application. It offers a more visual interface, but today I will focus on the terminal version since it's more flexible for developers. Now I will launch OpenCode and wait a moment for it to install. Alright, the installation is complete. Now I will run it. We can run it using the OpenCode command. This is the main interface. Here we can interact with the AI model directly in the terminal. One key feature is that we can choose which model to use. By typing /model, we can see the available options. For this demo, I will select Minimax M2.5, which is a free model. This is useful because it allows users to balance between cost and performance. And in addition, OpenCode provides auto/command, so we can configure settings or control behavior easily. Now I will create a new empty project to start from scratch. I will ask the model to build a to-do list web application. But instead of generating code immediately, I will use plan mode first. The idea of plan mode is to let the model think before coding. It will break down the problem into smaller steps, such as defining feature, UI structure, and file organization. As we can see, the model outlines the full approach, including what feature to implement and how the application should be structured. This step is important because it allows us to review and validate the plan before moving forward. Now let's proceed in plan mode. You can see that OpenCode will not write any code to your folder in plan mode, no matter what you ask it to do. Now I will proceed to build mode. At this stage, the model generates the actual implementation based on the approved plan. We can see that the code is already structured and ready to use. Now I will run the application. This is the to-do list application. We can add new tasks, mark them as complete, and manage them interactively. This demonstrates how we can quickly go from an idea to a working product with minimal effort. Next, I will demonstrate another use case, improving an existing project. This is a calculator project that already has basic functionality. Instead of building from scratch, I will ask the model to enhance it. I will start again with plan mode to review what change the model suggests. As we can see, the model proposed improvements such as refining the layout, simplifying the interface, and enhancing usability. This step helps ensure that the change aligns with what we want before modifying the code. Now, I will proceed with build mode to apply this improvement. As you can see here, the OpenCode already fixed our code in the calculator project. This is the update version of the calculator. As we can see, the interface is now cleaner and more user-friendly compared to before. Next, I will go back to our presentation. Underlying that demonstration is the sophisticated three-layer architecture. The interface layer handles the user direct interaction through the terminal UI and IDE plugins. Below that, the context engine manages project memory to SQLite persistent vector memory and specialized server protocols. Finally, the intelligent layer acts as the brain, routing requests to the chosen AI models or local inference engines. The brain of the system uses large language model for code generation, but it enhances their accuracy through a process called Retrieval Augmented Generation or RAG. It utilizes embedding for semantic search, which allows the assistant to find relevant code snippets based on meaning rather than just keywords. This system supports multiple models, both local and cloud-based, while remaining context-aware of the project's specific structure and external dependencies. One of the standout technical aspects is that OpenCode understands the entire code base, not just single files. It maps project structure using abstract syntax trees, or AST, and performs static analysis to track how different components interact. By maintaining session memory, the assistant can provide more accurate, architecturally relevant response that align with the existing logic of the software. Actual workflow is split into two distinct modes to ensure the developer remains in total control. In plan mode, accessed via the plan command, the assistant analyzes the code base in a read-only state to generate a step-by-step implementation roadmap. The developer then reviews this plan for accuracy, scope, and potential dependency conflicts. Once approved, the build mode or build execute the plan, writing the code, running tests, and preparing the final commit for the developer review. When comparing these two to the commercial alternatives like Claude or GitHub Copilot, OpenCode provides significant advantage in privacy and flexibility. While commercial tools offer strong IDE integration, they often lack the same level of customizable privacy control or the ability to run entirely on local infrastructure. OpenCode is designed to bridge the gap between powerful reasoning and the need for a customizable, secure environment. When evaluating the advantage, the primary strength is the extensible, open-source nature of the project, which prevents vendor lock-in through flexible model support. Technical teams benefit from strong context awareness and privacy-friendly options that are often missing in commercial products. However, there are trade-offs. It may require more manual setup and configuration compared to plug-and-play apps, and performance is naturally tied to the chosen model. Local models, while private, may also be less powerful than their cloud-based counterparts. Looking toward the next phase of development, the roadmap is focused on increasing autonomy and technical depth. A major priority is the transition toward agent-based AI workflows, enabling better automation for complex, multi-step tasks. There are also plans for direct integration with CI/CD pipeline and effort to improve the performance of local models. Finally, the introduction of multimodal capabilities will allow the assistant to process and understand the relationship between code, user interface, and technical documentation simultaneously. The long-term vision for this technology points toward a fundamental shift toward AI-native development environments. Deep integration of these capabilities suggests a path toward a reduced need for manual debugging and significantly faster development cycles. Ultimately, this leads to more personalized coding assistants that can adapt to a specific developer style and unique project requirements. To conclude, OpenCode represents a developer-first approach to AI assistant. By prioritizing privacy, integration, and extensibility, it has the potential to significantly reshape how software development workflows are approached in the future. This concludes the technical overview of the OpenCode Assistant. Thank you for your time and attention throughout this presentation.